Let's talk about multiplying and dividing radicals. First, let's talk about multiplying. See, I give you 2 radical 3 times 7 radical 5. Now, there's kind of a rule you want to know about with radicals, and especially multiplying and dividing. What I call innies and outies don't go together. You can't add, subtract, multiply, or divide them. So you want to keep with the outside parts, what's on the outside of the radicals. Multiply the 2 and the 7 and you get 14. And then multiply what's inside the radicals, and that was 15. 15, the square root of 15 cannot be written as a product of 2 numbers, one being a perfect square, because 3 and 5 are not perfect squares. So this is simplified. So 14 radical 15 is your answer. All right, let's try another one. 5 radical 6 times radical 3. Now what you could do is, you can do this one of 2 ways. You can write it as 5 times radical 3 times 2 times radical 3. You can look at that as, wow, hey, I see a pair of the same numbers. Radical 3 times radical 3 is square root of 9, which is 3. So anytime you have a radical times that's a same number, it's going to be that number. Like if you had radical 7 times radical 7, that's 7. But in this case, we have radical 3 times radical 3, that's times 3 on the outside, have a 2 left over inside. So that's going to give you 15 radical 2. That's one way to do it. A lot of people like to do it another way. They like to just simply multiply these numbers, the 6 and 3, so they would get 5 radical 18. And then they would think, well, 9 times 2 is 18. So they would have 5 times the square root of 9, which is 3. And then have a radical 2 left over and give you 15 radical 2. Both methods are okay. Sometimes when you multiply these numbers, they get so big, it's hard to break it down into thinking what times what gives you that inside number. So this is just an alternative method to break it down, make it easier to work with. Okay, let's add variables to it now. Let's take square root of 9x squared y cubed times the square root of 4xy. Now these guys are not too big a number, so let's just go ahead and multiply everything inside. So we got 9 times 4, that's 36. Now remember, when you multiply, you add the exponents. You have x squared times x to the first. That's a first, and this is a first on the y also. So you're going to have x squared times x, that's x cubed. And then you have y cubed times y to the first, that's y to the fourth. Now let's do each part separately. Square root of 36, hey, that's nice. That's a perfect square root. That's 6. And then we have to remember how we handle the variables. We have to divide 2 into each one. How many times 2 go into 3? 1 time. So you're going to have an x on the outside, leave a little space for a y. And then you have 1 left over inside. Now how many times does 2 go into 4? Twice. So you're going to have y squared with no y's left over inside. And that's your final answer. Okay, now let's talk about dividing radicals. Say I give you the square root of 28 x cubed divided by the square root of 7x. Now in the same manner that radicals can be broke apart into 2 separate radicals like I have there, they can be put back into 1. Let's do that. Why am I saying to do that? Because you can simplify. What's 28 divided by 7? Well, that's 4. Now, what do you do with the powers? Well, don't forget this x in the bottom, that has a power of 1. So you're going to take 3 minus 1, it's going to give you x squared. Now we just do each part separately. Square root of 4 is 2. And how many times does 2 go into x, 2 and x squared? It's 1 time, so you get 2x as a final answer. It doesn't always work out that nice, but I just wanted to show you how simplifying can make it work a whole lot easier. Second one. Okay, let's add a little bit more. We're going to put some numbers on the outside of the radicals. like 15 times square root of 60 x to the 6th over 21 times square root of 5x. Let's work with the outside parts separately from the inside parts of the radicals. 15 and 21. Only thing you can do with it is really just simplify those numbers. 3 goes into 15 5 times, and 21 7 times. Now the radical 60 over to x to the 6th, and you can simplify. You can think of them as all under one radical. 60 divided by 5 is 12. And then subtract the powers of x. 6 minus 1 gives you 5, so you're going to have x to the 5th inside. Now you're not done. You still have to simplify that radical. So we're going to write the 12 as 4 times 3. Square root of 4 is 2. And then take that 2 times this 5, giving you 10. Now you got to figure out what you're going to do with leaving this remaining 3 right here. That stays inside. And then how to handle the power of x to the 5th. Well, divided by 2. 2 goes into 5 how many times? Twice. So you're going to get x to the 2nd, or x squared, with 1 left over inside, all over 7. Seems a little complicated, but you just got to deal with one part at a time. It makes it easier to break it down into steps. Okay, now we're going to add some special situations now. So I'm going to star this one. You could have square root of 100 over 3. You say, well, okay, that doesn't look too hard. Well, square root of 100, you can write that as 10. And can't simplify the radical of 3 in the bottom, so you're going to leave it like that. Well, you know what? They will not have an answer like that because in most mathematics, they want to have what's called that denominator rationalized. So you're going to have to multiply top and bottom by the square root of 3. Square root of 3 divided by square root of 3 is 1. So you're multiplying by 1, so you're not changing anything, so it's legal to do it that way. And remember earlier, if you take a square root or a radical times itself, you get the number inside. So the square root of 3 times square root of 3 is 3. And the top part, you're just going to have 10 radical 3. And you can't do anything with this. Some people like to take and cancel these 3's. No, that's a square root of 3, and this is 3. They're not the same number. All right, one more special situation. Say you had 5 divided by 3 minus radical 7. And you looking at that, well, I know we have to get rid of the radical 7 because we can't have a square root in the bottom. Someone may have to roll. I don't know. That's just how it is. Well, you can't multiply by radical 7 over radical 7 like we did the other idea with number 3. You're going to have to multiply by the bottoms, what's called conjugate. Since it's a binomial, conjugate means looks the same but opposite in sign. So 3 plus radical 7. Do the same thing to the top. That's the same number on top of each other. 3 plus radical 7 over itself is 1. You're not changing when you multiply by it. Now, here's what you do. When you have a binomial times its conjugate, you really don't have to FOIL. You don't have to do the first, outer, inner, last. You just have to do the first and the last because the O and I out of FOIL parts will cancel. So let's take a look at what you got. You got 3 times 3, that's 9. You got a negative radical 7 times a positive radical 7, that's a minus. A negative times a positive is a negative. Radical 7 times radical 7 is 7. Notice no more radical in the bottom. Now the top part, what you're going to do is you're going to take that 5 and you're going to distribute to both parts. So 5 times 3, that's 15. And then 5 times radical 7, you can only write it as going to be plus 5 radical 7. You cannot multiply those because that's outside a radical. This is inside a radical, so you just basically put them together. All we have to do is clean it up a little bit. We got to do the 9 minus 7, which is 2. So you have 15 plus 5 radical 7 all over 2, and you're done. Now you could see it written another way. They could take 15 divided by 2 plus 5 radical 7 divided by 2. And that's just a property of fractions, how you can break it apart into 2 separate terms. If you want, you could see it this way or the way I wrote it previously.